Okay, start recording. Today we're going to do differentiation. Okay, let's see. So differentiation for P3, I'm going to split into 6 parts. There will be basic rules, basic differentiation, application, parametric differentiation, implicit differentiation, and the modeling question. For your P3, we will focus on these 3. Okay, so which is parametric differentiation, implicit differentiation, and the modeling question. That means in order for students to actually take care of these 3, we will expect students to actually know about the fundamental, okay, which is the basic rule, basic differentiation. Okay, so let's try to go through the rules again. Okay, so basic rule. Okay, first we have the first principle of differentiation. Okay, if y equals to fx, then dy dx equals to limit of h tends to 0, f of x plus h minus fx over h. This is the one that actually help us to derive all the rules. And number 2, if we have a plus minus of 2 expressions, we can actually separate them before we do our differentiation. Number 3, if I have a multiple in front of the fx, I can take out the multiple. Okay. Number 4, if I have a constant, differentiate of the constant will go to 0. Okay. Then number 5, if we have u times v, okay, product rule, we will get u prime v plus v prime u. And number 6, if I have a u over v quotient, okay, a fraction, so you will have a u prime v minus v prime u over v squared. Okay, number 7, if you have a fgx, a composite function, we apply a chain rule here, become a f prime bracket gx times by g prime x, or we write in the informal form, which is dy dx equals to dy dA times dA dB times dB dx here. Okay, this will be helpful when we're dealing with the questions later. Okay, so by now you should actually aware of the rules. Okay, you are not required to know the proof for this rule. Okay, it's because it's not covered in the syllabus. For further math students, if let's say you want to know about the rules, okay, it's actually better for you to learn about the proving of them as well for further math student. Next, we go for the basic differentiation. Okay, number 8. If I have a x power n form polynomial, okay, bring down the power minus by 1. Okay, if I have a ex, number 9, if differential of ex goes to ex, proof by definition of ex. Or if we have a e of fx, then we can bring down the power. Okay, so differentiate of the power, bring it in front and right, copy back the e fx here. Number 10, ddx of a ln x equals to 1 over x, okay? Or ddx of the ln fx, here you have a fractions of f prime x over fx, okay? Number 11, if I have a differentiate of sine x goes to cos x. Number 12, we will have a differentiate of cos x goes to negative sine, okay? Number 13, differentiate of tangent go to secant square. Then number 14, differentiate of secant go to secant x tangent x. Number 15, differentiate of the cosecant goes to negative cosecant cotangent. Okay. Number 16, differentiate of the cotangent x go to negative cosecant square. And number 17, differentiate of the arctangent equals to 1 over 1 plus x squared. This will be the 2020 syllabus. Okay, number 19, if I have a power of kx, okay, I can actually get a kx k ln a. Okay, but over here for this formula, you do not memorize the formula. You have to do it by using the log rules. Okay, as you can see, there are some questions here that are marked as a star. Okay, that means this star question can be appear as an exam questions that you are expected to know how to actually do the proving. Okay, those are not marked, okay, will be proved by the first principle or definition. So we will see one by one how to actually prove for them. Okay, number 10. Let's see. I just write on the side here. Number 10. So let y equals to ln x. So x equals to ey. Then dx dy, according to rule number 9, you will get ey. The original question is in the form of y equals to ln x. So what I'm trying to get is to get dy dx. So I flip them upside down. Okay, so I get 1 over ey. So ey earlier is x, isn't it? So I have a 1 over x. So this is how we actually get rule 10. Okay, so next one, rule 12. How do I know differentiate of cos equals to negative sine? First of all, we will already assume that students know differentiate of sine go to cos. Okay, therefore, so the dx of cos x, okay, according to P1 rule, the cos x can be written as sine of 90 minus x. Sine of 90 minus x. Then we apply chain rule. Okay, differentiate of sine become cos. Keep the inside. Multiply by differentiate of the inside, which is minus 1. Therefore, what I get is a negative of cos 90 minus x. So back to P1 again, cos of 90 minus x is a negative sine x. Cos of 90 minus x is sine x, so therefore you get negative sine x. So with the rule 11 and 12 together, you should able to see there's a connection. The sine go to cos, cos go to negative sine go to negative cos, and negative cos go back to the sine again. There will be a cycle of it. Of course, the arrow that I'm drawing right now is differentiation. Okay, then integration will be the reverse process of it. Okay, next, let's look at 13. What do we get for 13? Okay, 13, I have a ddx of tangent x. Okay, ddx of tangent x. Tangent from P1 can be written as sine over cos. Sine x over cos x. Okay, then I apply quotient rule here. Okay, apply quotient rule. U prime v minus v prime u over v squared. U prime v minus v prime, okay, v prime u over v squared. Okay, so you see that there's a cos square x plus sine square x over cos square x. That actually give you 1 over cos square x. That actually give you secant square x, like this. Okay, so you'll get secant square x. Yeah, you see. Okay, number 14. Okay, number 14, how do I actually get 14? So 14, okay, differentiate of the secant. So the dx of secant x. Okay, I can write as the dx of cos x powered by negative 1. So I applying chain rule, bring down the power minus by 1, okay, become minus 2. Then differentiate of the inside become negative sine x. You will see that the negative got cancel off. Okay, you have a sine, and a cos, don't combine them together. Okay, you have a sine and cos, combine them together, become tangent x. Okay, and you have a cos, a single cos by itself, it becomes secant x. So you will have a secant x tangent x here. Okay. Number 15 and 16, I leave it for yourself to do the proving. There will be a similar working like what we have up here. Okay, for the 15 and 16. 17. Okay, 17. And then not enough space. Let me go down. 17. Let me have some space first. So 17. 17 is the x of arctangent x. Okay, give us 1 over 1 plus x squared. As I say, this is a 2020 syllabus. You need to know how to actually do this. Okay, how does it work? So what do? Is we let y equals to arctangent x first. Then x equals to tangent y. Then I'm going to do dx dy. According to the rule above, okay, you know that differentiate of the tangent becomes secant square, so it becomes secant square y. Okay, the original question is in the form of y equals to arctangent x, so therefore I'm supposed to get dy dx. So I flip this dx dy upside down, so I get dy dx equals to 1 over secant square y. Then this secant square y we change into trigo, so it become 1 plus tangent square y. Please understand, at this moment, we will assume students already okay with the trigo topic. Okay, we expect students to know, oh, you see secant square y. Okay, I know that it's related to 1 plus tangent square. Then this tangent y is x, therefore it's a 1 over 1 plus x square. Please understand, you will, for us, the teachers, we will have some level of expectation from chapter 1 to 3 that you are expected to know. Okay, then comes to 18. 18, rule 18, we have, just now, I have differentiate of a of kx. Please understand, this is no longer e, okay, it's a is any number here, okay. So how do we actually get this answer? Okay, as I say, you do not memorize the formula, you do it from the long rule. Okay, let's see. Okay, so dx of akx. Okay, so first of all, by using the log rule, okay, we can write in the form of ELN of akx. What exactly is this rule? From the log chapter 2 that you have done before, okay, you should know that k equals to ELN k. You already know this rule, okay. As I say, we do have expectation. Okay, so over here we have dx of e of kx ln k, ln a, sorry, kx ln a. Please understand, k is a number, ln a is a number. So from differentiation, okay, differentiate of the power bring to the front, therefore we have k ln a. Okay, then at the back we copy the same thing again. Okay, do you remember ekx ln a is originally akx? Okay, so k ln a of akx is the answer. Okay, so this is how we actually get the thing. You will be expected to know about the rules. Okay, the why we cannot memorize the answer, because we have a different variations of the question. Okay, maybe an example of ddx of 2 power x, maybe ddx of 2 power x squared, or maybe ddx of x power x, or maybe ddx of 2 over sine x, 2 power sine x, for example. So therefore, all of these questions you will be expecting to know how to apply the green color pathway to the log rule. Okay, so you can actually try by this yourself. Okay, so over here there are some exercises. Okay, you can see a bunch of questions here. So each sections, okay, I crop from different textbook. So with the answers, question answers, question answers, question answers. Okay, if possible, you try to finish all the questions here. Okay, if possible, you try to finish all the questions here. Okay, because without building up the fundamental, it's very difficult for you to actually continue with the next sections. Okay, next application. Okay, analysis of graph. Okay, if you think that you haven't really mastered the differentiation yet, you can pause here, practice the question first before you continue from this on section onwards. Okay, so now, okay, so application, we're talking about analysis of graph. This is just some sort of reminder from the P1 differentiation. Okay, over here from the graph, I draw a sketch of the graph. So y equals to 0 0.1, x plus 3, x minus 2 square, x plus 1 cube. Okay, and from then I generate the green curve. From the green curve, I located some point A, point B, point F, point C, point D, point E here. That actually can help us to actually identify the property of each of this point. So increasing function, okay, so we need to understand which point they actually give us dy dx greater than 0. Okay, so for example, point F here give us dy dx greater than 0 because it's going up. Decreasing is the one that going down. So going down, you have point D. Stationary point is where the point, the gradient equals to 0. So point A, point B, point C, point E. Okay, so you have A, B, C, and E will be all stationary point. Okay, where the dy dx equals to 0, the gradient value equals to 0. Then the turning point, it fulfill two conditions. Okay, dy dx equals to 0 and d2y dx square not equals to 0. What are the point? So you have a point A, point C, and point E. So E does not, the point B does not fulfill this. Then minimum point, the point that fulfill dy dx equals to 0, and the second differentiation is a positive. So it's a point A and point E. Okay, maximum point is the point that gives you dy dx equals to 0, and second differentiation lesser than 0, that will be point C. Okay. Then you have a point of inflections. Point of inflection is the point where it changes the curvature. So from maybe from the smiley face to sad face, or sad face to smiley face. Okay, so it changes the curvature. So this is the point. Okay, so what are the points that actually fulfill point inflection that actually give you the shape like this? You can see point B here initially is a sad face, then become a smiley face up here. So point B. Point F as well, initially is a smiley face, then become a sad face. So point F. Point D as well, initially is a sad face, now become a smiley face. Point D. Yeah. Okay. Then horizontal point imperfections. Okay, the point that fulfill d2y dx squared equals to 0 as well as dy dx equals to 0. Okay, but the third differentiation not equals to 0. You can actually observe 25 and 21. 25 and 21, the common point that you have is B. So this is point B. Okay, this is the point B. Horizontal point inflections. Okay, then after that, you have equation of tangent, equation of normal. Okay, to find the gradient value. Okay, then this is the perpendicular, negative perpendicular. Okay, so you can actually get the equation of tangent, equation of normal. The rest of it will be just explaining of the questions. Okay, how you actually deal with the questions. Okay, next. Okay, now we enter the real deal. Okay, which is a parametric differentiation. Okay, parametric differentiation. So what exactly is a parametric differentiation? Okay, what exactly is a parametric differentiation? First of all, you need parametric equation. Remember in P1, okay, when we talk about function, we talk about one to one, one to many, many to one, many to many. Okay, then we say that one to one and many to one, they are function. Okay, because we say function can do calculus. And we also say that one to many and many to many, they are non-function. Okay, non-function, we cannot do calculus. But if I can write non-function in the form of parametric form into parametric. Okay, then I can actually do my differentiation integration. Okay, these are some example of the parametric equation, some shape. Okay, this is not as your syllabus. Okay, this is not your syllabus, just show you as an example. Okay, so I have parabola. Okay, they actually give you a sloping parabola like this. The Cartesian equation is actually y squared equals to 4ax. Okay, but the parametric equations is in the form of x equals to at squared, y equals to 2at. So where the t here, we call it parameter. T as a parameter. Okay, you can actually imagine it like this. The x and y, father and mother, they're having argument. They don't want to talk to each other. So they talk through the third party, their son. Okay, the son is the middleman that actually connecting the x and y. So the t here. So over here, the axis is still be y and x. Okay, but it's the t that help to actually connecting the dots. Then we also have circle. Okay, a circle, we have the Cartesian equation in the form of x minus h squared plus y minus k squared equals to r squared. Okay, where the parametric equation is in the form of x equals to r cos theta plus h, y equals to r sin theta plus k. We also have the ellipse. Okay, this is horizontal ellipse. The one that I draw is horizontal ellipse. That means that A is longer than the B. Okay, A is bigger than the B. Horizontal ellipse. So I have x equals to A cos theta, y equals to B sin theta. I also have rectangular hyperbola A in the form of xy equals to c squared. Of course, this is something that you know as a reciprocal graph. Okay, reciprocal graph. But this one, to be more specific, we say in the we define it in the form of rectangular hyperbola type A. Okay, so you will see this is the first and the third quadrant. The parametric equation is in the form of x equals to tt, y equals c over t, and you have a hyperbola. Okay, so x over a squared minus y over b squared. This is a horizontal hyperbola. Because it can be left-right hyperbola or up-down hyperbola. Okay, this is a left-right hyperbola. So x will be in front. Okay, then I have a x equals to a secant theta, y equals to b tangent theta. So you can see here, start involving in getting more and more complex. Now, even involved with the trigo now. Okay, then you have a rectangular hyperbola b. Okay, so you also have an asymptotes here. Okay, where their asymptotes are actually perpendicular. So x squared plus y squared equals to a squared. So I have a x equals to a secant theta, y equals to a tangent theta, like this. Okay, at the bottom, I wrote some additional thing. This is for the further math syllabus. You can ignore it for now. Okay. Then I want to get gradient function. So what exactly is this gradient function? The gradient function is in the form of dy dx equals to something. Okay. So since I have this parametric equation, so how do I actually get my gradient function? Let's say I'm using this example. Okay. So x equals to ct, y equals to c over t. So I have dx dt equals to c. I have dy dt equals to negative c over t squared. Therefore, combining these two together using chain rule, dy dx become dy dt times d dtx. Okay, so I have a negative 1 over t squared as your answer. So you can actually do fill in the blanks for the rest of them. But as I say, this is not an official syllabus. Okay, this is just an example for this particular section. That's all. Okay, so then after that, if let's say I want to get equation of tangent by using the parametric form, so I will have, by using the same example, I will have y minus c over t equals to negative 1 over t squared. Okay, x minus t. x minus ct. My mistake. Okay, we got ct here. Ct is a general point of x, c over t is a general point for y. Okay, then after that, if let's say for equation of normal, so I will have y minus c over t equals to negative 1 over t squared and x minus ct. Therefore, I have y minus c over t equals to t squared of x minus ct. That is equation of normal. Okay, of course, again, depends on how complicated is the questions. Yeah. Okay. So what exactly that you need to know from this session? Okay. So skill number 1, you need to able to convert, okay, parametric equation into Cartesian equation. So let's say you have x equals to 2t, y equals to t squared here. Okay, convert parametric equation into Cartesian equation. Okay, so we have a convert. Okay, so I have y equals to t squared, y equals to t squared. So x equals to t equals to x over 2. So y equals to x over 2 the whole thing square. So y equals to x squared over 4. Of course, this is an easy example. You may have difficult example. Okay, for example, the example 7 up here. So you have x equals to sine t, y equals to sine 2t. So y equals to sine 2t. Okay, x equals to sine t. So y equals to sine 2t. So you will have y equals to 2 sine t cos t. Again, here we expect students to know about the double angle formula. Okay, then after that I can actually replace sine t with x. So y equals to 2x cos t. So I have a cos, if I write cos t as my subject, I have a y over 2x. From here, okay, I borrow my trigo formula, sine square t plus cos square t equals to 1. So sine t is actually x, so I have x squared, and cos t is y over 2x squared equals to 1. That will be your Cartesian equation. Okay, of course depends on whether the question want you to rearrange the form or not. So if let's say for rearranging, okay, so y squared over 4x squared equals to 1. So y squared equals to 4x squared 1 minus x squared, like this. Okay, depends on how they want it to be. That will be skill number 1. Okay, so in order to practice for this skill, so there are 2 sets of questions here. The first set is a non-trigo question. The second set is a trigo question. So of course for trigo question, we expect you students to remember chapter 3, trigo formula. So your objective is to combine the x and y together without the t. So the answer is over here. Same goes for the trigo type. Okay, the your objective is to combine the x and y together without looking at the t. Okay, then your answer will actually look like this. Okay, you can actually pause here and take a moment to work it out. Make sure that you actually remember your trigo. If you're already okay with the upper part, okay, which is converting the parametric equation into Cartesian equation, then comes to skill number 2. Okay, so that means you need to find the gradient, okay, in terms of t. So example 1, find the gradient of the point P where t equals to 2, okay, when given this and this. So I have a x equals to t cubed plus t. So dx dt equals to 3t squared plus 1. and I have y equals to t squared plus 1. Then I have the dy dt equals to 2t. Then after that, I need to get my dy dx. Please remember, gradient of the curve is dy dx, not dy dt, is not dx dt. So we apply chain rule, dy dt times by dt dx, dt dx. Okay, so I have a 2t over 3t squared plus 1. Okay, when t equals to 2, when t equals to 2, so I will have a dy dx equals to 2 times 2, 3, 2 square plus 1. So 4 over 13 as your answer. Okay. Then, of course, you also may have questions that involve with trigo. Okay, this time they're asking for equation of normal. Okay, equation of normal. So I have x equals to 3 sine theta. Okay, so dx d theta equals to 3 cos theta. Okay, y equals to 5 cos theta. So dy d theta equals to negative 5 sine theta. Okay, then I have dy dx equals to negative 5 sine theta over 3 cos theta. You no need to simplify it, okay, because that's not what we want. We want the equation of the normal. So you can just leave it like that in that form. Okay, if you really want, you can actually write in the as a tangent. Okay, so now when theta equals to pi over 6, so my x equals to 3 sine pi over 6. Okay, pi over 6 means 30 degree. So for the sine is 1 over 2. So 3 times 1 over 2. So it's 3 over 2. Then my y is 5 cos pi over 6. Okay, so I have 5 of square root 3 over 2. So I have a 5 over 2 square root 3. Okay, then I also have dy dx value. Okay, with a negative 5 over 3 of tangent pi over 6. Pi over 6 is 30 degree, so I get a negative 5 over 3 or 1 over square root 3. So we have a negative 5 over 3 square root 3 here. Now we talk about equations of normal. Okay, equation of normal. So y minus y1 equals to negative 1 over negative 5 over 3 square root 3. Okay, sorry, square root 3 at the bottom. 3 square root 3 of x minus x1. So y minus 5 over 2 square root 3 equals to 3 square root 3 over 5 x minus 3 over 2. Of course, in the end, depends on question want you to simplify it or not. So you simplify, then you simplify. Okay. Over here, again, you have exercises. Okay. This exercise is to ask you to find the dy dx. Then the answer is over here. Next, we have implicit differentiation. Okay. Okay. Again, this is also for non-function. Okay. So how do we actually deal with non-function? Okay, before I actually show you what exactly is implicit differentiation, I'm going to show you by using example first. Okay, so I have 4 columns here: explicit by x, implicit by y, implicit by x, implicit by y. Of course, at the moment you have no idea what I'm talking about. Okay, but my objective is to find dy dx for the equation x squared plus y squared equals to 4. Okay, so I have my x squared plus y squared equals to 4. Okay. Due to a usual differentiation, I supposed to write y as a subject first. So y equals to plus minus square root of 4 minus x squared. Okay, there is a plus and minus. Okay, maybe for this to make things easy, okay, I'm going to let y equals to the one positive 4 minus x squared. Okay, 4 minus x squared. Then after that, I do my differentiation. Okay, so I have dy dx, bring down the power minus by 1. Okay, with differentiate of the inside. So 2 cancel off, negative x over square root of 4 minus x squared. Okay, this is the answer that I get. Okay, now let's move on to the second column. Okay, I have the same questions, x squared plus y squared equals to 4. Okay, earlier I make y as a subject, this time I make x as a subject. So x as a subject will be plus minus square root of 4 minus y squared. Again, there is a plus minus sign. So for simplicity, okay, I'm going to let x equals to the positive of 4 minus y squared. Okay, then now I'm going to do dx dy. Okay, so 1 over 2, bring down the power. So 4 minus y squared, negative 1 over 2, differentiate of the inside, negative 2y. Okay, 2 cancel off, negative y over square root of 4 minus y squared. At this moment, you see that this is dx over dy, so I'm making them as a dy over dx. Okay, I get a negative square root of 4 minus y squared over y. Okay, there's one problem. Okay, I got first column and the second column, okay, both dy dx, but they are totally different. You can see this is in the x form, this is in the y form. Okay, never mind, let's leave it like that first. Okay, let's continue with the other two columns. So same questions, x squared plus y squared equals to 4. Okay, so what I'm going to do, I'm going to do differentiation for both sides. Okay, I'm going to do ddx on both sides. Okay, ddx. So I will have a x squared plus y squared. Okay, I have a 4 here. So ddx. So the reason I do ddx is because this column is implicit by x. So I do ddx. Okay, I didn't do any algebra rearranging like earlier. I didn't do that. Okay, I just differentiate straight away. So next, I have a ddx of x squared plus ddx of y squared and ddx of 4. Okay, ddx of x squared, okay, this being nice, okay, because they are the same alphabet x and x together, so I get 2x. But the middle term here, I have x and y, they are different alphabet. Okay, I cannot differentiate them straight away, so I need to use chain rule and make them the same alphabet first. Okay, I'm going to do it like this. So you'll see that dy here cancel off, I still get back to ddx. But furthermore, the y and the y here now become the same alphabet. And now this one goes to 0. So I have a 2x plus dy of 2y, dy of y squared become 2y, then dy dx equals to 0. Okay, by writing dy dx as my subject, I have a negative x over y. Now if it become even worse, now we have 3 columns that are totally different. Okay, never mind. We continue with the last column. So x squared plus y squared equals to 4. At the third column, I do ddx. Okay, the fourth column, I do ddy. So I do ddy on both sides. So ddy on both sides, like this. So I have a x squared plus y squared. Then I have a 4 here. Okay, so according to differentiation rule, there's a plus in between. So I separate them. Okay, I separate them. Okay, dy of 4 is a constant, so go to 0. This one nothing new. So dy of y squared, they are the same alphabet. Okay, also very good. So I give me 2y. Okay, but here I have d dy of x squared. They are the different alphabet now. This is y outside, this is x inside. So I need to make them the same alphabet. So d dx of x squared, okay, times by dx dy. Some students will ask me that how do I know where do you put the dy and the dx, dy above, dy below, and so on. Okay, whatever that you do, when you apply chain rule, when you do cancelling, you should go back to the same place. Okay, you should go back to the same place. So now you have a d dx of x squared. Okay, they are the same alphabet now. We can do differentiation. It becomes 2x of dx over dy plus 2y equals to 0. Okay, simplify. I have the dx over dy equals to negative y over x. Since the question is asking for dy dx, okay, since the question is asking for dy dx, so I flip them upside down. Dy dx equals to negative x over y. And finally, the third and the fourth column, they give us the same answer. What about the first and the second? Okay, let's go back. The first column, I have a negative x over square root of 4 minus x squared. Remember earlier we let y equals to positive root of 4 minus x squared. So the bottom here, this is a y. Okay, it's the same with the third and fourth column. What about the second column? Same thing, we have x let x equals to positive root of 4 minus y squared, right? Just, okay, so you will see that this one can be replaced by x, or negative x over y. So they are all the same. Since they are all the same, why do we need to learn about implicit differentiation? Okay, it's because most of the time, the equation that we get cannot be rearranged by algebra. Maybe there will be a questions that I'm not able to rearrange and write y as a subject. If I cannot do that, I cannot do it the usual way. Therefore, I need to do it in the implicit form. I will need to do it with the implicit form. Okay, this is implicit differentiation. The harder questions will be implicit with the product rule, implicit with the quotient rule, and implicit with the chain rule. When you practice your question, your past question and so on, you will start dealing with this type of questions. Okay, so of course, it will increase the challenges lah. Okay, so let's see one example. We want to find the dy dx value at the point 1, 1. So I give us this equation. Okay, so I do d dx straight away. So for xy squared plus d dx of 6x squared over y, okay, equals to d dx of 10. Okay, then this one you need to aware that it's a product rule. This one is a quotient rule. Okay, and this is a constant. So product rule. Okay, differentiate u, keep v. So differentiate u, keep v, plus keep u, differentiate v. This is my first bracket, plus this is quotient rule. Okay, differentiate u, keep v, minus keep u, differentiate v over v squared equals to 0. Equals to 0, not 10, 0. Okay, so I start differentiating. So d dx of 4x, so I have a 4, okay, y squared. Then I have a 4x. This is a d dx of y squared, so I should make them the same alphabet, y squared, and dy dx here. Then plus, so this one, I have a 12x and a y minus 6x squared. So this is my dy dx over y squared equals to 0. Okay, let me finish simplifying this. So 4y squared plus 4x, then become 2y, then dy dx plus 12xy minus 6x squared dy dx over y squared equals 0. Okay, I'm not going to rearrange because the question asking for dy dx value. Stay with the x equals to 1 and y equals to 1. So all I need to do is just substitute x and 1 in x and y as 1 inside. So I have 4 plus 8 dy dx plus 12 minus 6 dy dx over 1 equals 0. So 4 plus 8 dy dx plus 12 minus 6 dy dx equals 0. 2 dy dx equals to negative 16. So dy dx equals to negative 8. That's your answer. So you don't need to go straight to rearranging if you okay. So you can think about what exactly is the question 1 first. If they want you to rearrange, then only you rearrange. If they don't want you to rearrange, don't bother to rearrange them. You're actually just wasting time. Okay. Then now, okay, these will be exercises. Okay, you actually can try it out. And finally is the modeling questions. Okay, modeling questions. So you need to know how to write the expressions yourself. Okay, so there are some example here. Okay, modeling questions. Okay, so you need to know how to read the question. Decay. Okay, proportional. Okay, number of particle. Okay, so equation rate of change. Okay, it say the rate. Okay, dn dt is proportional to negative n. How do I know that it's written like this? So the particle, okay, the number of particle I read it as n, so number. Okay, proportional, decay, negative. Proportional to the number of particle remaining, negative n. So I have dn over dt equals to negative kn. So this will be the equation that we're looking for. Okay. Number 10. A population is growing proportional to the size of population. Okay, right now. So dp dt. Okay, population proportional to the p. Okay, proportional to the p. So dp dt equals to kp. Okay, so this will be the equation, the differential equation that we're referring. So the top example, you have this. So you also have the one harder here. Question 9. Fluid flow out of a cylinder tank with the constant cross section. At time t minutes, the volume of the fluid remaining in the tank is V meter per meter cube. The rate at which the fluids flow in meter cube per minute is proportional to the square root of V. Okay, so flow out getting smaller and smaller, proportional to the square root of V. Okay, cylindrical, so it's a cylinder shape. Okay, it's a cylinder shape going up. Okay, the depth H inside remaining. Okay, so satisfied, show that. Okay, show that. So let's see how to actually do this question. Okay, so to save some space, let me write it up there. Okay, so I have V equals to pi r square h. Okay, it's a constant cross section, so this one pi r square, no changes, it will remain the same number. So it will change according to the h that we have. Therefore, over here I will have dv dh equals to pi r square. Okay, because this is a number. Number 2, I have flowing out. dv dt is proportional to negative of square root v. It says square root v. Negative because it's getting flow out, getting lesser and lesser. So dv dt equals to negative k square root v. Okay. So now the question asking for the h dt. Okay. So I using chain rule. So I have dh dv times by dv dt. So I put them together. This is dv over dh. This is dh over dv. So I put them upside down. And this one, I put it together like this. Negative k square root v. V is pi r square h. So negative k square root pi r square h over pi r square. Okay, negative k pi r square square root h over pi r square. You will see that this whole thing here is just a number. Okay, you will see that this whole thing there is just a number. Therefore, you will get a negative k. This is a star here with a square root h, which is fit with the questions. What the question wants. Okay. The rest of the two questions, okay, I can actually leave it to you. Okay, if you have a problem, you can actually ask me in school. And this is all the 6 sections of differentiation topic. So you have a basic rule, basic differentiation, application, parametric differentiation, implicit differentiation, and modeling questions. Again, exam will be highlighted according to these 3. Okay, and we expected students to are capable to do the previous 3. Okay, that's all for differentiation. Stop recording.